Hello, my students in grade 10. This is our mathematics lecture, the first lesson in grade 10, and the title of lesson is Sets. What are the objectives of our lesson? Objective number one, we will define a set. Number two, identify special sets. Three, represent a set in roster notation and builder-in notation. Number four, specify subsets of a set. Five, define and create a Venn diagram, then identify its symbols. Six, find complement of a subset, the parts of a set, cardinal if a set, and number of elements of a set. Number seven, specify the set of numbers in math. Then, how can we differentiate or know the difference between a set and a couple? Objective number nine is not included this year. The definition of a set. As you can see here, we have cherry, banana, apple, and kiwi. These are fruits. So I classified all these fruits in a set. As you can see, in front of the set, we opened a brace, and after we finished, we closed the brace. And in between cherry, banana, to apple, and kiwi, I used commas. In the other one, I have numbers 1, 3, 5, 7, etc. Also, I opened braces, and when I finished, I closed the braces. Between these numbers or these digits, I also used commas. This is how we can list elements in a set. Now I will talk about these sets. Each one of these that you see inside the set is represented by X. So cherry is represented by X, banana is an X, apple is an X, and kiwi is an X. So any element in the set is represented by X. So what is the definition of a set in math? A set is a collection of objects forming a group. So this set forms a group of elements, and this set, the second set, forms a group of elements. Each object inside the group of elements is called an element of a set. So cherry is an element, banana is an element, apple is an element, kiwi is an element. 1 is an element, 3 is an element, 5 is an element, 7 is an element. An element of a set can be of any kind. So an element inside the set can be any kind of things. It can be people or name of people, letters, numbers, colors, shapes, whatever. To represent a set, we name it using capital letters, enclose all its elements or members between two braces separated by a comma. Let me give you an example. Consider a set which is called A. So what is the name of the set? It's A. So I named the set using capital letter A. Equal, I enclose all the elements of set A between two braces. So I open a brace, I list the elements of set A. When I finish, I close the braces. How many elements do we find in set A? Let's count. 1, 2, 3, 4, 5. So the number of elements in set A are 5. What do these elements represent? 1 is odd, 3 is odd, 5 is odd, 7 is odd, and 9 is odd. So all these elements represent odd numbers less than 10. If I look at the elements of set A and I asked you, 5, is it an element of set A? Yes. So we say 5 belongs to set A. 3, is it an element of set A? Yes. So 3 belongs to set A. 4, is it an element of set A? Do we find 4 between the elements of set A? No. So we say 4 does not belong to set A. This is the symbol of belong to, and this is the symbol of does not belong to. We have special sets. Number one, universal set. What do I mean when I say universal set? The universal set contains all the elements in regard to a particular subject. For example, if I asked you, let me in a set list all the letters of the word children. So I write all the letters of the word children. Because all the letters exist here, or I can find all the letters of the word children, no missing letter, so this is called the universal set of the word children. Number two, void or empty set. It is denoted by this symbol which we call it phi. In this set, we have no element. It contains no element. For example, if I asked you, what is the set of students having a grade 104 over 100 in an exam? You tell me, nobody can get 104 over 100, so it is a void or an empty set or a phi set. Number three, singleton set. The word singleton comes from the word single. It contains one and only one element. For example, if I asked you, what are the even prime numbers in math? You say 2 is the only even prime number. So 2, the element 2 forms a set which is singleton because it only contains the digit 2. Number four, we have the doubleton set. Doubleton comes from the word double. It contains two distinct elements. So in this set, I only have two elements. For example, if I asked you, what is the set of solutions of the equation x squared minus 4 equals 0? If we solve this equation, we get x equal plus or minus 2. So the set E, which is the solutions of this equation, it has only two values or two elements which are minus 2 and 2. So it's doubleton set. Number five, the equal sets. If two sets have the same elements, we call them equal sets. Example, set A has 1, 2, 3. Set B has 2, 3, 1. A and B are equal since 1 as an element exists in A and it exists to B. 2 belongs to A and 2 belongs to B. 3 belongs to A and 3 belongs to B. I don't care about their order to say that the two sets are equal. So in an equal set, I can write the elements in any order. For example, the set A, which is 1, 2, 3, and B, which is 2, 3, 4. Are they equal? No. Why? Because here we have 1 in A. We do not have 1 as an element in B. We have 4 in B. We do not have 4 in A. So these two sets are unequal. How can I represent a set? Representation of a set. To write a set in math, we have two ways. The roster notation or in extension. How do we write the roster notation or extension? The elements of the set are listed in a row. So we list here the elements of the set in a row way, surrounded by braces. Before we start, we open a brace, and after we finish, we close the brace. Elements are separated by a comma, and elements in the set should not be repeated. For example, the set of digits, we are listing the set of digits in math. We open brace, we say 0, 1, 2, 3, 4, 5, 6, 7, 8. In between, we write a comma, then we close the brace after we finish. The set of letters of the word mathematics, I open the braces, then I list all the letters of the word mathematics. But as you can see, The letter M is repeated, so I only list it one time. The word A is repeated in the word mathematics, so I only list it one time. So elements in a set are only listed once. No repetition is allowed. And I can list the letters of the word mathematics in a set in any order. So the elements in a set can be written in any order and they should not be repeated. This is the roster notation or in extension when I'm listing the elements of a set. Number two, the builder notation, or we call it comprehension. This way is used to build sets by classifying elements according to their properties. So in this way, we are describing what do the elements of the set mean. For example, if I give you the set E in roster notation 2, 3, 5, 7, 11, 13, and you are going to write it in comprehension or builder notation. If I look at these numbers, I can see that these are prime numbers. So I say each of them is called X or is represented by X, X such that X is a prime number less than 17. Let's write an exercise. The first exercise, we will write sets in extension or in roster notation. E equal X such that X is a letter of the word Lebanon. So to write it in roster notation, I should list all the letters of word Lebanon. As you can see in word Lebanon, the letter N is repeated. So how many times do I list it? I list it only once. Since these letters are written in capital letter or uppercase, they should be written in uppercase or capital letter when listing them. So I write L, comma, E, comma, B, comma, A, comma, N, comma, then O. Set F, X belongs to Z. What does this mean? We know that set Z in math, which is the set of numbers, they can be negative, zero, and positive. So what are these elements? X is between negative 3 and 2. Here, minus 3 less than X less than or equal to. Do we have or equal on minus 3? No. So is minus 3 included between the elements of F? It's not included. What is the first element after minus 3 or before minus 3? It is minus 2. So I start listing from minus 2 until 2. So I ask again, is 2 included in my set? Yes, because we have or equal to. So when listing the elements, I say set F is minus 2, minus 1, 0, 1, 2. Set G, X belongs to N. N is a natural number from 0 to plus infinity. 0, 1, 2, 3, 4, 5, 6, etc. X cubed minus 4x equals 0. So I'm looking for the elements that form the solution of this equation. X cubed minus 4x equals 0. To do this, I should solve this equation to find its solutions. I can see that this side of the equation is not factorized. So I factorize it. I take a common factor x and I factorize. I have x squared minus 4 equals 0. Inside the parentheses, I have degree 2. So I can also factorize x squared minus 4 using remarkable identity 3. So I write x into x minus 2 into x plus 2 equals 0. Now it is a product equation. I can find the solutions of x. Either x equals 0 or x minus 2 equals 0 or x plus 2 equals 0. If x minus 2 is equal to 0, then x is equal to 2. And if x plus 2 is equal to 0, then x is equal to minus 2. So these are the solutions. But do I take all these elements in the set? Of course, no. Why? Since x belongs to n. Can x be negative? No, so x equal minus 2 cannot be taken. So I only take 0 and 2. So set G is only 0 and 2. Now set H, x such that x is a prime number less than 10. So I should list all the prime numbers less than 10, which are 2, 3, 5, and 7. I equal x such that x is a divisor of 12. What are the divisors of 12? We all know that divisors start from 1. So 12 is divisible by 1, 12 is divisible by 2, it's divisible by 3, by 4, by 6, and by 12. So these are the elements of set I. Of course, I will say again or remind you again, I start my set with its name, I open braces, then I close braces. Set G x such that x is a vowel letter in lowercase. So I should list all the vowel letters in lowercase, A, I, O, U, and Y. K x such that x is a solution of the equation x squared minus 25 equals 0. Of course, here I should close parentheses after the comprehension notation or the builder notation is done. So now if I want to list the elements of k, I write k equal open braces. I solve the equation x squared minus 25 equals 0 using remarkable identity 3. Then I find the solutions. So x is equal to 5 or x is equal to minus 5. Then set k is 5 and minus 5. Now, in the second exercise, we should write in comprehension. So we should describe the given set. Now, I will be given sets in extension and I will write them in comprehension. A equal A, P, L, E. What do these letters represent? Of course, the word apple, since P is not repeated. So I write x such that x is a letter of the word apple. Of course, in the word apple, we have double P. I only list it once in the set since no repetition is allowed. B equal 1, 2, 4, 8. What do these represent? These are the divisors of 8. 8 is divisible by 1, is divisible by 2, by 4, and by 8. So x such that x is a divisor of 8. C equal minus 3, 0, 3. These are the solutions of the equation x cubed minus 9x equals 0. Set D 5, 10, 15, 20, 25. These are multiples of number 5. If I multiply 5 by 1, it gives me 5. 5 by 2 is 10. 5 by 3 is 15. 5 by 4 is 20. 5 by 5 is 25. So D equal x such that x is a multiple of 5 less than or equals 25. E equal A, E, I, O, U. But as you can see here, the letters are written in uppercase. What are these letters? These are the vowel letters in English. So x such that x is a vowel letter written in uppercase. F equals 0, 1, 4, 9, 16, 25, 36. These are square or perfect squares of numbers from 0 until 6. So x such that x is a perfect square less than 37. The subsets of a set. If we are given two sets E and F, set E is a subset of set F if all the elements of E are also elements in F. We can denote this by E subset F. So this is the symbol of subset. What does this mean? For every element belongs to E, for every X belongs to E, X belongs to F. So we read it for every X belongs to E, X belongs to F. Set E is not a subset of set F if there exists only one element in E which is not in F. Now, the void set or the empty set or the phi is a subset of all sets. So phi is a subset of all sets. Now E is not a subset of F is denoted in this way. This means For every x belongs to E, x does not belong to F. Given two sets, A, which is 1, 2, 3, 4, 5, B is 2, 4. We should fill the blanks with belong, does not belong, subset, not a subset, or equal. If I'm talking about an element with respect to a set, the element belong or does not belong. If I'm talking about a set with respect to a set, I use subset. 3, it belongs to A. Why? Because between the elements of set A, I find 3. 5, does it belong or does not belong to B? If I look at set B, do I have the element 5? No, so 5 does not belong to B. Set 2, 3 is subset of A. Why? Because in A, I have a subset which is 2, 3. 3, 4, is it a subset of B? No. Why? Yes, I have 4, but I do not have 3, so it's not a subset. As we said, phi is a subset of all sets, so phi is a subset of B. Is B a subset of A? Yes, because 2, 4 are also found in set A. Every set is a subset of itself, so it's called the full set, and every other set is called the proper set. Let me give you an example. Suppose I give you the set T, which is Toyota, Mercedes, BMW. Let me list all the subsets of T. First, the first subset is Toyota, so it's taken as a set. The second subset is Mercedes, BMW. Together, Toyota and Mercedes form a subset of T. Toyota and BMW is a subset. Mercedes and BMW is a subset. The set itself, Toyota, Mercedes, BMW, is called the full set. It's also a subset of itself. And phi is a subset, or the empty set is a subset of the set. So this is called the full set, and the others are called the proper sets. Let us solve an example about the equal sets. We should state whether the two sets A and B are equal. Are these two sets equal? Yes, since all the elements of A are also the elements of B, regardless of their order, so set A is equal to set B. A is x such that x is a positive odd integer where x is less than 7 and b equal 135. Let us say A is written in comprehension. We should write it in extension. What are the positive odd integers where they are x less than 7? They are also 135. So since set A has the same elements of set B, then they are equal. Set A is equal 0. This is a singleton set. Why? Because it has one element which is 0. 0 is an element. It's a digit. It's a number. B equal 5, so it's an empty set. Are these equal? No, so they are not equal. A equal x such that x is a whole number where 3x equal 5 and b equal 5. So if this is a whole number, then let's solve x equal 5 over 3. Is 5 over 3 a whole number? No. So set A is phi and set B is phi, then they are equal to each other's. The Venn diagram, let me talk about the Venn diagram. To represent our sets, we represent them in a drawing called the Venn diagram. What does the Venn diagram do? It uses overlapping circles to show the relationship between two or more sets. A circle represents a set where all the elements of the set are listed. So in the circle, I have the name of the set and we list all the elements of the set inside the circle. Let me talk about the simple Venn diagram. In a simple Venn diagram, we have only two sets. Two circles, each circle represents a set with all the elements listed in it. So when I draw the Venn diagram, in each set, I list all the elements of the set in it. The overlapping area where the two sets intersect or meet or share elements between the two sets represents the elements which are common in the two sets. So where the two sets intersect, this is the overlapping area. In this area, I write all the common elements between the two sets or the shared elements. The other two areas are not overlapping, represent the elements that are in one set but not in the other set. Let me talk more. This is the Venn diagram. We are given two sets A and B. So this is the overlapping area where the two sets A and B intersect. So this is A intersection B. Here, the other area or the outside area, here we find only the elements that are only in set A, and here are the elements that are only in set B. So this area has the shared or the common elements between A and B. In the Venn diagram, we have an intersection of two sets. This is the intersection. What does this say? X belongs to A and X belongs to B. So here, X belongs to A and X belongs to B. In this area, X belongs to A, but X does not belong to B. In this area, X belongs to B, but X does not belong to A. This is the intersection and the other two areas. Union of two sets. Union is represented by A, U, B, A, union B. It is the whole Venn diagram. Union, it is the elements in A and the elements in B together, but no repetition is allowed. So what does A union B mean? X such that X belongs to A or X belongs to B. Complement of a set, all the elements that are not in the set but are in the universal set. Suppose I have a universal set U, which is 1, 2, 3, 4, 5, 6, 7. And we have a set A, which is 2, 4, 6. What is the complement of A? We represent it by A dash above it. This is A complement. It is elements in the universal set but not in A. So I have 1, 3, 5, and 7. This is A complement. How can I create a Venn diagram? We draw a circle for each set. We first list the shared elements or the common elements between the two sets in the overlapping areas. After that, we list the remaining elements in the remaining areas. Let U equal A, B, C, D, E, F, and T equal A, C, F. U is the universal set. I want to find T complement. T complement, as I said, elements in the universal, not in T. It is B, D, E. A equal 3, 4, 6, 8, and B equal 1, 2, 3, 5, 6. A intersection B, the element X belongs to A or X belongs to, or sorry, the element X belongs to A and X belongs to B. They are 3 and 6. So the only elements shared between A and B, which is the intersection, they are 3 and 6. A union B, X belongs to A or X belongs to B, 1, 2, 3, 4, 5, 6, and 8. It is the two sets together without repetition. Two sets are disjoint if they have no common element, so their intersection is equal to phi. Complement of a set. When I talk about the complement of a set, as I said, it is the elements in the universal but not in the set itself. Complement of a subset of a set, for example, A union B as a complement is equal to A complement intersection B complement. A intersection B complement equal A complement union B complement. So I first find A complement, I find B complement, I make their union, it's equal to A intersection B complement. Parts of a set E, denoted by PE, it is the set of all subsets of E, including the set itself and the empty set. So PE equal A, we open braces, sets A such that A is included in E, where A is a set. Phi is included in E, then phi is called an empty part of E, and phi belongs to P of E. E included in E, which is the full set, it is part of the set. For example, if I have set E equal A, B, C. We should find all the parts of E. I write PE equal, I open the brace. First, the first part of the set PE is the phi. Then I take each element alone as a set. Then I take each two elements together as a set. After that, I take the full set itself. So, as I said, the set A belongs to PE, but the element A does not belong to PE since all the elements of PE are written as sets. Now, the cardinal of a set, it is denoted by card E. It is equal to the number of elements in set E. For example, I gave you, let S equal A, B, C, and B equal dog, cat. I want to find card of S. Card of S, I count the elements of S, which are 3 elements. Card B, I count the elements of set B, which are 2 elements. Always in an empty set, the cardinal of A is equal to 0. In singleton, it's equal to 1. And in pair set or in doubleton set, the cardinal of E is equal to 2. Number of elements in parts of a set. Suppose I have a set. I got the parts of the set which are listed in a set itself. How can I find the number of elements in parts of a set? It is equal to 2 to the power n. What is n? It is the cardinal of the set itself. Suppose that again set S and set B, I want to find the number of elements in parts of S or P of S. It's equal to 2n. What are the number of elements in set S? They are 3. So 2 cube is equal to 8. In set B, 2 cube, this is a typing mistake. Let me correct it. This is parts of set B. It is equal 2 to the power n. How many elements do we have in set B, which is 2? So 2 squared is equal to 4. Always the power of an empty set is a null set. It contains no elements. So the power set of an empty set is a set containing a null set. This is the null set which has no elements in it. This is what we discussed in class in our lesson, which is the sets. Finally, I will talk about the set of numbers. In math, I have different kinds of numbers. I have the natural numbers represented by a capital N. When we talk about natural numbers, we are talking about the numbers which are from 0 to plus infinity. 0, 1, 2, 3, 4, 5, 6, 7, etc. Some books consider natural numbers starting from 1 till plus infinity, and the numbers starting from 0 till plus infinity, they call them whole numbers. But in our book, the natural numbers start from 0 until plus infinity. When I talk about a set which is n star, it has all the positive numbers, of course non-decimals, without the 0. Set Z has the negative numbers, the positive numbers with 0, of course without decimals. Z star, it is the set of all positive and negative without the 0. Set N is included in set Z, or set N is a subset of set Z. What do we mean by set Q? It is the irrational numbers. The irrational numbers are all the numbers that can be written in the form of B over A. They can be written as a fraction, where B belongs to Z and A belongs to Z star. Why? Because A cannot be 0. A should be different from 0. Also, set Z is a subset of set Q. R is the set of real numbers. It includes all the numbers, naturals, integers, rational, and irrational. So set N is a subset of set Z, set Z is a subset of set Q, and set Q is a subset of set R. When we talk about a couple in math, like the couples we used to deal with last week in our lesson orthonormal system, it is denoted by parentheses XY. It only has two numbers in it. X is a number and Y is a number. They are ordered. What do we mean by ordered? They cannot shift places. We always have X and Y. Always X is the first element and Y is the second element in XY. Since X is different from Y, so the couple XY is different from YX. The first couple I'm talking about now is 2, 3. So X is 2 and Y is a 3. In this couple, X is a 3 and Y is 2. Note that the couple 2, 3 is a couple, while this type of writing is called a set. So always a couple, we put it inside parentheses, and the set, we put it inside braces. The Cartesian product or the Cartesian product, we will leave it for later. Please watch the video well of the discussion, and if you have any question, contact me. Thank you.